Hello everyone. Today we can discuss about Johnson counter in the subject digital principles and system design. So Johnson counter is another one name given to this is creeping counter. Okay. So it's a modification of ring counter is one of the example for synchronous counter. So in Johnson counter, the complemented output, that is the inverted output of the last stage flip-flop is connected to the input of the first stage flip-flop. So for designing of an n-bit Johnson counter, we require n flip-flops and it is also known as 2 n-bit Johnson counter or mod 2n Johnson counter. And another two special names given to them are twisted ring counter because the only difference from ring counter is it is going to connect the inverted output of the last stage flip-flop from your normal ring counter. So it is also called as twisted ring counter. Another one name given it is switch trail ring counter because it overcomes the limitations switching going to overcome the limitations of ring counter. Mainly it reduces the number of flip-flops required for designing. So half number of flip-flops compared to the ring counter it is going to use. So how it is going to be designed? So mainly it is the applications is walking counter, mobile counter, switch tail counter, or the other names given to them. So the clock signal is in Johnson counter, as per the is a synchronous counter, it's common clock pulse. And as per we are using T flip-flop here for the implementation of Johnson counter. So the inverted one, the last Q bar output is given as input. So initially it will be in reset condition and all the bits are in 000. Now you start applying one bit by one bit. So it is a 4-bit Johnson counter we are going to see here. So the clock pulse is applied. So what happens based on it is first 000 it is going to, so first bit you are going to give. So first bit the last Q bar is given because Q bar is connected, so it becomes 1 during the second clock pulse. Since here it is QD bar is connected to the first flip-flop, here it has 0 the complemented output 1 QD bar. So the first bit becomes 1 and remaining all the bits 0. Now we are going to apply the second clock pulse means what happens? It will be shifting the data. So shifting the first what is it will be shifting this 1 to 1 here, and since it is 0, it becomes the complement 0 bar, it becomes 1. Okay. And likewise, all the bits are transferred and now it becomes 1. Now, as it is 1, here it becomes 1 bar. So it becomes 0 here. It is shifted here. It is shifted here. It is shifted here. So likewise, at last, it becomes, this complement becomes here 0, 0, 0, 0. That will be repeating again. So that is nothing but the way in which it is going to operate. Starting with 0, 0, it is represented by the state diagram. Reset bit 1, 2, 3, 4, 5, 6, 7, 8. 8th clock pulse. And it is going to repeat by the 9th clock pulse. So 4 bits equal to 2 into n. So how many clock pulse needed? 8 clock pulse needed to return to your original state. Okay. As it is a 4-bit. So the operation which we explained is shown here is designed with T flip-flop as shown here. 4 stages, 4 flip-flops connected in series type or cascaded. Initially 0 and then it becomes 100, 1100, 1110, 1111. Likewise, it will become becoming the 0. Okay. So this is a timing diagram representation based on your output. So first it is 0, 0, 0, 1, initially 0, then 0, 0, 1, 1, 0, 1, 1, 1, then 1, 1, 1, 1. It becomes then 0, 1, 1, 1. Likewise, it will be going to repeat. Okay. So what are the advantages of using this? As same number of flip-flops, but it can't put twice the number of states. It uses D flip-flop as well as JK flip-flop. Is used to count the data in a continuous loop. Is a self-decoding circuit. What are the disadvantages? It can't count in the binary sequence as in the order 0, 0, 0, 2, 0001 like that, it can't count. More number of states remain unutilized because we have only, as it is a 16-bit, sorry, 4-bit. 4-bit means 16 states are there, but how many states are used? Only 9 states are used. Number of flip-flops is one of the number of timing signals because n by 2. It can be constructed for any time, one at a number of timing sequence. Can't be constructed. So what is the applications? It is a synchronous decade counter or divider circuit. It's in the hardware logic design, ASIC and FPGA design, it is used. 3-phase square wave generator, it is used. Frequency divider, that is the divider circuit, normally decade counter. So divide the frequency of the clock signal by varying the feedback. So all these applications, and this one and this one are the major applications which is used with the type of Johnson counter. Okay, thank you, students. I hope you have understand this.